Hello my students, how are you? Prep 3, today we'll explain and solve all questions talk about statics. What's the probability? First question, show the correct answer. If A and B are two multiple exclusive events from the sample space of random experiment, then probability A of intersection B. We know A and B here disjoint. They are disjoint. Then the intersection between A and B it will be null set phi, and the probability between A intersection B it will be 0. And the answer will be 0. Okay, if he asked about probability we must write 0, and if he asked about intersection between A and B we can write null set phi. Okay, means the answer here will be 0. Number 2, if probability of A is equivalent to 4 product by probability of complement of A. What's the probability of A? We can solve this example by finding the relation between probability of A and probability A complement. The summation between together equal 1. Okay, he gives you this information, probability A equal 4 times probability A complement. Then we can cancel probability of A and write probability A complement plus probability A complement. The result equal what? We can cancel probability of A and write 4 probability of A complement because they are equivalent. Probability of A equivalent to 4 times probability of A complement. We can add together here, the result will be 5 probability A complement. The result will be 1. Then probability A complement, the result will be 1 over 5. Now we can find probability of A, finds the difference between 1, write 1 subtract by 1 over 5. It will be 4 over 5. 4 over 5 we can convert to decimal by product numerator and numerator by 2. So the result will be 8 over 10. The result will be 8 tenths. The answer here will be 8 tenths. Okay, it shows letter D. Next question, number 3. If A subset of B, then probability A union B. We know A subset B meaning A inside B, like this. Set of A and set of B. Then probability A union B here, we can write the union, give me the greatest set here, the result will be probability of B. Then the solution will be letter B. Okay, next question. If A and B are two mutual exclusive events of sample space in random, meaning A and B disjoint, then probability of A difference B it will be probability of A because they are disjoint, intersection between together equal null set. The result will be probability of A. The probability of certain event it will be 1. Okay, certain it will be 1. Choose letter B. And if A and B two events sample random experiment, probability of A 0.6, intersection 0.4, he won't find probability of A difference B. You must know this rule, probability A difference B it's equal probability A subtract by probability A intersection B. Because if we have null set or Venn diagram here draw, we have here is the intersection and we have A and B. We won't find A difference B. This part, A difference B equivalent to probability of A subtract by intersection. So you can write intersection was 0.4 subtracted by 0.6. The result will be 0.2. Means the answer here will be 0.2. Okay. Next question down here. If an event of the sample space is a random experiment and probability A complement equivalent to probability of A, they are equivalent, then each one of them equal half, equals half plus half equal 1. Then the probability of A equal half. They are equality, the summation between together equal 1, then each one of them equal half. Next question. An experiment showing for the probability appearing prime numbers. Prime numbers, we know prime numbers, A number has 2 factors only. This number can divide it by 2 and 1. We know prime numbers like 2, 3 and 5. We called it prime number because each prime number has only two factors, can divide it by itself and one only, like 2, 3, 5. So we have 3 digits. In the probability of prime numbers equivalent 3 over the total number 6, because we have the die has 6 digits. Then the result will be 3 over 6. The result will be 1 over 2. Next question down here, number 9, the probability of impossible event. Impossible will be 0, okay? Impossible will be 0. Choose letter A. Next question. Faraday ruled once. In the probability of appearing the number less than or equal to 3, okay? We can write less than or equal to 3, write 3, 2, 1. Then the probability of this event equivalent the number of elements divided the total number, the result will be 1 over 2. 3 over 6 will be half. Next question, A and B to even simply, we have subset B. It's meaning A lies inside B. Then probability A union B will be give me the greatest set here will be the result will be probability of B. Next question, if a complementary event of A in the sample space of random experience, the probability A union A complement, it will be what? It will be 1, because here will be A union A dash, or A complement union A give me the sample space of all results, so the result will be 1. Okay, the answer here will be 1. Okay, answer here probability it will be 1. So this question will be 1. Okay, then probability of A dash union A equal 1. But if he asked about A complement union A, it will be S. So you must change the answer here. Okay, change the answer, choose 1. My students, the probability, this question is important. If you cancel probability, cancel B here, then the result will be S. But if he write probability, you want to find the number, probability will be 1. Choose letter B, cancel letter A and write letter B. Okay, next question, the probability of fair students 0.2. Failure students, and the probability of success we have 1 subtract by 0.8. Success 1 subtract by 0.8 will be 0.1 subtract by 0.2, it will be 0.8, it will be 8 over 10. And you can simple this also by divided by 2 numerator and denominator. 8 divided by 2 4 and 10 divided by 2 is 5, and the result will be 4 over 5. Next question here, if A subset B, it's meaning A lies in B. Okay, A lies in B, the probability of A difference B, it will be null set. The probability it will be 0. Probability of null set, the result here will be 0. Okay, the answer here will be 0. Understood? You must know it's important. Okay, next question, if A subset from space randomly, then and probability A complemented twice, probability is in probability of A equal. We know probability A plus probability A complement, the summation between together equal 1. And he give you this information such that probability A complement was twice probability of A. You can put the value of probability of A complement here, twice probability A here, right? Probability of A plus probability plus twice probability of A. I will cancel this and write the equivalent. Okay, twice probability of A equivalent to 1. Then we can add together here 1 plus 2 is 3, right? 3 probability of A equivalent to 1. Then probability of A it will be 1 over 3. The result here 1 over 3. Okay, understood? Tips here. Okay, next question, if A event from the sample space randomly experience, probability A complement equal 1 subtract by probability of A. Next question, if A subset B, C meaning A lies in CB, then the intersection between A and B it will be A. So probability of A intersection B equal probability of A. The intersection will be A because A lies in B, A inside B. The answer will be letter A. Next question. If the event from sample is based randomly and probability A equivalent to probability A complement, then each one of them equal half, because half plus half equal 1. Half, choose letter C. Next question down here. If A event from sample is based randomly experience and probability A equals 3 probability B dash, then probability A equal, okay, we know probability A plus probability A dash equivalent to 1. He gave me this information. Probability A is 3 twice by 3 by probability of A complement. Okay, then 3 product by A complement. He give me this information. Look at here. Probability of A equivalent to 3 times probability A complement. Then I cancel this and write 3 probability A complement plus probability of complement. It will be 1. 3 plus 1 equal 4. Then we have product by probability A complement equal 1. The probability A complement, it will be 1 over 4. Then probability A will be equal what? We know the summation between together equal 1. Then probability A, it will be 1 subtract by 1 over 4, it will be 3 over 4. And the answer will be 3 over 4. Okay, next question. If A and B are two events, the sample is based randomly, probability A 0.3 and probability B complement, they are equivalent, then probability of B equivalent to probability of B complement. Each one of them equal half because they are equivalent. They are equivalent, then the summation between together equal half. Okay, summation together equal 1, then 1 equal half plus half. Okay, and he give you also probability A intersection B was 0.2. He won't find letter A, won't find probability A union B. A union B, we can write probability of A plus probability of B subtract by probability A intersection B. We have probability of A give me probability of A 0.3, write 0.3, and probability of B, it will be half. Half, it means 0.5 is half. Subtract by intersection here. Then we get 8 together. 8 chances subtract by 2 chances, the result will be 6 chances. And what about probability A minus B? A difference B, right? Probability of A subtract by probability A intersection B. Probability of A 0.3 and the intersection 0.2, then the difference between together equals 0.1. Next question. In the output figure, he won't find solution here. First, I will explain the steps. Okay, first, letter A. He won't find probability A intersection B. We know A intersection B here equal what? Look at here, intersection between A and B, we have 2 and 3. And probability of A intersection B, we have 2 digits. From the total number of all elements in space randomly here, we have 1, 2, 3, 4, 5, 6. Then we have 2 over 6. Then the result will be 1 over 3. In the number of elements here, we have 2 digits over 6 digits. The number of elements in sample space randomly, the result will be 1 over 3. And letter B, he won't find A union B. A union B here we have 5, 2, 3, 1 and 4. So probability A union B, we can write the number of elements here 1, 2, 3, 4, 5 divided by the total number in sample space randomly, we have 60 digits. Letter C, you won't find probability A difference B. We know A difference B equivalent to 5 only because we have one digit here. So the probability here, we have here 1 digits from 6 digits. We have 1 digit, 5 here repeating 1 times 1 digits. A difference B, we have one element here from total number 6 digits. So the result will be 1 over 6. Next question. He won't find probability A intersection B in this example. He gives you this information so you can find by write the rule. Probability A intersection B equivalent to probability A plus probability B subtract by probability A union B. Probability of A was 0.4 plus probability B 0.7 subtract by union here 0.8. The result will be 1.1 subtract by 0.8. The result will be 0.3. And this question letter A, question letter B. He won't find probability A difference B. It will be probability A subtract by probability A intersection B. Probability A was 0.4 subtract by A intersection B was 0.3. So the difference between together equal 0.1. If A and B are two even samples and only, you won't find. Okay, it's the example I solved it from 1 minute like this. You remember? You can find probability A union B, find by write the rule. Probability A plus probability B subtract by A intersection B. We have probability A was 0.8, probability B 0.7, subtract by intersection 0.6. So the result will be 0.9. This is letter A. Letter B, the probability of non-occurrence of A, probability A dash. It will be 1 subtract by probability of A. Probability of A was 0.8, then the difference between together equals 0.2. Okay, these tips about this question. Next example here. We won't find probability A intersection B. You can write the rule. He give you probability of A union B in each of the following. We have two even samples, double experiment. We have probability A and probability B. If probability of A intersection B equal 1 over 8, he won't find the first condition. He won't find probability A union B. We can find A union B by write probability of A plus probability of B subtract by probability A intersection B. Probability of A was 1 over 2 and probability of B 1 over 3 subtract by intersection between together 1 over 8. So the result here, we can write the least common multiplication between three denominator. Here we have 24. 24 divided by 2 12. 1 times 12 12. 24 divided by 3 8. 1 times 8 equal 8. 24 divided by 3. 1 times 3 3. 12 plus 8, 20. 20 minus 3 is 17. This is question letter A. Okay, and what about question letter B? We have second condition. He won't find union if A and B are two dimensional exclusive events. It's meaning disjoint. It's meaning A and B disjoint. Okay, A and B like this. The intersection between together equal null set 5. This is the probability about A intersection B. It will be 0. So this question letter B, he won't find probability A union B. You can write probability of A plus probability of B only because the intersection between together equals 0. Since the probability of A 1 over 2 and probability about B equal 1 over 3, we can collect together, the result will be 5 over 6. Next question. We have black contains of 20 identical characters from 1 to 20. Then the sample space randomly here we have from 1 to 20, 1 to 20. Okay, in the number of elements in space randomly we have 20 numbers. So letter A, he wants to find the number which divisible by 3, right? 3, 6, 9, 12, 18. Okay, 3, 6, 9. Well, so the probability of event A equals the number of elements here 1, 2, 3, 4, 5, 6 over 20. 6 over 20, you can sample by divided by 2 numerator and numerator. 6 divided by 2 3 and 20 divided by 2 equal 10. And question letter B here, divisor by 3 or 5. It's meaning union. He won't find the number can divide it by 3, write 3, 6, 9, 12, 15, 18, and also can divide it by 5, write 5, 10, 15, don't write 15 again, and then write 20. Okay, and then you can count how many digits you get it divided by the total number 20. So the probability of B equivalent to, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 over 20. Okay, next question, number 7. We have a probability A and B, and want to find A and B in two cases. First case, A and B mental exclusive events, meaning intersection between together equal null set, and probability it will be 0. So which are letter A, probability A intersection B equals 0. Okay, so about letter A, we can find probability A union B. You can write probability of A plus probability of B equivalent to, because they are disjoint. In first condition, they are multiple exclusive events, meaning disjoint. We have A and B, the intersection between together equals 0. So probability of A, we can write 0.3 plus 0.6. The result will be 0.9. Okay, and this question letter A. Question letter B, you won't find union between together A union B when intersection was 0.2. The intersection here is 0.2. So you must write the rule: probability A plus probability B subtract by probability A intersection B. We have probability of A. Probability of A was 0.3, and probability of B was 0.6. Subtract by intersection 0.2. The result will be 9 minus 2, 7. The result will be 7 tenths. Next question. If A and B are two events sample spaced randomly, he give you probability of A and probability A difference B. He won't find probability A. You want to find probability A in first condition. Look at here. The section was 1 over 12. Okay, first step, I will draw Venn diagram to understand what steps. We have here two set A and B, and their difference. Here's the intersection, and here A difference B, and here B difference A. Okay, and this intersection. He want A will be probability of A difference B plus probability A intersection B. So probability of A equivalent to probability A difference B plus probability A intersection B. Okay, he give you the example probability of A minus B, it will be 1 over 4. And also give me first condition here. Look, A intersection B was 1 over 12. Then you can collect together by 8. Right, the least common multiplication between together is 12. 3 times 4, 12. 1 times 3 is 3. Then the result will be 4 over 12. The result will be 1 over 3. It's the first condition. And second condition, when B subset of A. Subset of A, it's meaning the intersection between together equal B and the union will be A. He wants to find probability of A. Then probability of A equivalent to probability A union B, because B subset of A. So if he won't find probability of A, it will be equivalent to probability of A union B. So you won't find here probability of A union B. We can find about this question here, letter B, probability of A. Look at here, question letter B. I don't find probability of A. In this condition, he tell me B subset of A. Okay, B subset of A. It's meaning probability of A equivalent to probability A union B. So you won't find here probability of A union B. Okay, how we find probability A union B? We can probability of A plus probability of B subtract by probability of A intersection B. Okay, probability of A, what is the number of probability A, right? We found it. Probability of A equal probability union. They are equivalent. So I want to find A union B. Okay, where A union B here? We can search about A union B, about A plus B subtract by intersection. Okay, I want to find probability. They are equivalent. This equivalent this. This is probability of A intersection B equivalent to probability of B in this condition. Understood? You can write also another relation about A union B. You can write probability A in second condition B subset A, probability of A equivalent to probability of A difference B here, this A difference B plus probability of B. You can collect together this part plus this part. This part A difference B. A difference B. You can write A difference B plus B. This B and here A difference B. You can collect together. So when B subset of A, B subset of A, you can find A difference B union intersection between together. We have subset B here, this B and this A. We can find A difference B plus B to collect together, give you set of A. Understood? Second condition, he tell me you in the example B subset of A. B subset of A, you can find A equivalent to B A difference B plus probability of B. A difference B here, he give you 1 over 4 in the example. And probability of B 1 over 3. You can collect together. 3 times 4 is 12. 1 times 3, 3. 1 times 4, 4. The result will be 7 over 12. It's an important question, okay? This question is very important. 7 over 12. The result will be 7 over 12. Again, probability A in second condition when B subset of A equivalent to probability A difference B plus probability of B. We can collect together to find probability of A. The result will be 7 over 12, okay? Next question. If A and B two events use information probability of A 2x, then calculate the value of x if A subset C. Okay, first condition here, he tell you A subset C. Look at here, we have this set of C and that set of A, and when A subset of C, we can find the intersection between together equal A and the union will be C. Again, you can see now, okay, again, in first condition, he tell you A subset of C. Look at here, A subset of C. It's meaning the intersection will be A and union will be C. He asked what? Asked the value of x. So he asked about probability of P. Where P here, B equal to x. We have set A, B, we have in C this type. نصلح دي نخليها بيها يا شباب، دي غلطة مطبعية. خلاص يبقى الكوتشن بتاعنا هنا عايز في الفيرست كونديشن لما الايه يكون سبسيت من بي، فاليونيون يكون A واليون intersection A and union B. He won't find probability of B. Listen, probability of B equal, we can find probability of B by A, probability of A and B difference A. This part and this part. When A subset B, we can find probability of B equivalent to probability of A union B. They are equivalent. When A subset B, then probability of B was 2x equivalent to probability of A union B. He give you A union B in the example was 0.8. Then x will be 0.4 divided by 2, then the value of x will be 0.4. It's free condition. This question letter A. Question letter B, you won't find probability of P when A intersection B is 0.1. Okay, I know probability of the rule. We know the rule probability of we can use this method to find probability of A union B equivalent to probability of A plus probability of B subtract by probability of A intersection B. Probability A union B, he give you in the example it was 0.8. Look at here, 0.8 here, right? 0.8 equivalent to probability A was 0.5 here. Look, 0.5 plus probability of B was 2x subtract by intersection was 0.1. You can solve the equation. 5 tenths plus 1 or minus 1 will be 4. 4 tenths subtract from 8 tenths will be 4 tenths equivalent to 2x. Then the value of x equals 0.4 divided by 2, it will be 0.2. So the value of x equals 0.2 here. Next question here. A bag contains 20 indicate characters numbers from 1 to 20. So the sample space randomly here 1 to 20. Okay, this is the sample space randomly here. And the number of element will be 20. Letter A, He won't find the number divisible by A. We can write the A divided by 5. Then event A, we can write 5, 10, 15, and 20. So the probability of A equal number of element 1, 2, 3, 4. 4 over 20, the result will be 1 over 5. And question letter B is odd and divisible by 5. Odd and also divisible by 5. We can write odd 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. And its meaning intersection, okay? And divisible by 5, we can write 5, 10, 15, 20. So the intersection between together, we have 15 only, and also 5. Yes, 15 and 5. 15 and 5 only. We have the number. So if you ask it about this word and its meaning intersection is odd numbers and divisible by 5, we can find right here odd numbers and divisible by 5 and find the intersection between together. So we have 2 digits. So the probability of event B, this event B, okay? In the probability of event B, we can count here 2 digits. We have 2 digits from the total number 20. 2 over 20, the result will be 1 over 10. So the result here will be 1 over 10. Okay, understood the steps? Okay, next question down here. If A and B mutually exclusive A, then the sample space randomly experience probability of A 0.3 or to B 0.4. He won't find union. We know A and B disjoint. A intersection B equal null set, and probability of A intersection B, it will be 0. Okay, in the first, he won't find probability of A union B. A union B equal probability of A plus probability of B. Probability of A was 0.3 and here 0.4, the result will be 0.7. And letter B, or question number 2, probability A difference B, it will be the same set because the intersection between null sets and probability of A difference B equal probability A, the value of probability A equals 0.3. Okay, the result will be 0.3 in second condition. Last question. Okay, easy questions. Okay, understood. Goodbye, my students.